Well, the simplest explanation for fog is really that it's kind of just if you took a cloud, a typical cloud, and just brought it down to the surface. Now that's the very easy definition, but there's a lot of other stuff going on. Basically, you have a lot of moisture content in the air, and it gets trapped at different levels, and again, you get the different types of fog basically due to that, but the ultimate formation is because you have moisture, and the moisture condenses into cloud droplets that rather than being, say, a couple miles up in the atmosphere or a mile up, you're talking about them being just a couple feet off the ground. Some of the more common fog types would be radiation fog, advection fog. You have the sea fog. Valley fog is just kind of another form of radiation fog. You just have an inversion that traps it in. So it's basically the same principles as that. So kind of interesting to see all the different types of fog though, and the different scenarios. You've of course got London with their fog. A lot of that can actually sometimes be blown in. Fog can be blown in, but it has to form somewhere originally. There's a couple different kind of fog seasons or things like that. You have the marine layer, which forms off of the coastlines of either the east or the west coast. It seems typically more on the west coast, but you get a trapped, what's known as a temperature inversion, and it's basically the same type of concept that happens with valley fog too, where you get cooling that takes place in the lower levels of the atmosphere, either right along the ocean waters or right along the valley surface, and then you have temperatures that actually start to warm with height, and that traps in any moisture. So you get this layer of fog, below it fog, above it just sun if you were to fly in an airplane. Fog can be tricky to predict. A lot of it has to do with humidity levels, and predicting humidity levels isn't, you don't have as much practice doing that as a meteorologist as, say, predicting snow or rain or thunderstorms. So that's part of it, and you get into the fact that it becomes a lot of pattern recognition. You know when winds blew in from the south the last time and you had snow on the ground, that you saw an inversion form where temperatures warm with height, and you saw fog form. So when you see the same type of situation coming in, that's probably, as a forecasting meteorologist, that's probably what I would look for, is just the same kind of pattern to repeat itself. Fog can definitely be dangerous, and it's dangerous only if you're kind of in a rush. If you're in a rush and there's a lot of traffic, things like that. But if you can't see more than a few feet in front of you, you can't see the other car, so you just have to kind of assume that they're still going. So if someone got into an accident, then you can't see the car in front of you that just got into the accident, so you hit them, someone hits you, and all of a sudden you end up with a situation like what happened out in Texas over Thanksgiving, where you get a 100-car pileup. Unfortunately, a couple of people were killed by that, and then dozens of injuries and things like that as well. So a scary situation can develop, and it can be avoided either by not driving on thick pea soup fog days, or just giving yourself the proper amount of following distance.